Okay, by shading the unwanted regions of the grid above, find and label the region R that satisfies the following 4 inequalities. Once again, I want to start off by identifying which line is which. So, I'm looking for an x equals 0 line. This is a line where all the x values are always 0, and that's going to run down the y-axis over here. I'm interested in when x is bigger than 0, which is clearly any point on this side where the x values are all positive, so I would need to shade the unwanted bit, which is over here. Like so. Now we need to figure out which of these lines is x plus y equals 7. Well, if we aren't sure, we could pick an x value, work out the y value that goes with it, and find out the line that includes that value. So let's say I pick x equals 3. If x equals 3, then y must equal 4. So I'd go along here and look for a line that has x equals 3 and y equals 4. There it is. So this must be the line x plus y equals 7. It will be simpler to do something like pick x equals 0 or y equals 0, but I've shown that before, so this is just an alternative. Now I'm interested in when x plus y is equal to or greater than 7. We don't think about numbers or algebra here, we just think about greater than, bigger than, above. I want values which are above that line, so I want to shade values below that line to get rid of them. So off we go. That area has been shaded. Those are all the values where x plus y is less than 7. So those two have been done. Now for the next one, we're interested in looking at this thing and deciding which of these two graphs represents y equals x. This is the very first diagonal line graph that we ever learn about, so hopefully you can recognize it very easily. But again, if you don't, then just pick an x value, figure out the y value that goes with it, and find out which of these graphs includes that point. If I say picked x equals 10, I know I'd need to find y equals 10 to go with it, and that's over here, so that must be this graph. I'm interested in values where y is bigger than x. So, that's values above this line. If you're worried about getting caught out like I nearly was before, then just pick a point and see if it satisfies that condition. If I pick this point over here, I can see that my y value, 12, is bigger than my x value, 8. That satisfies that condition, so that's where I want to look. That also means I need to shade the rest of these points down here underneath that line. So there's the rest of my shading, eliminating the bit I'm not interested in. The final graph is x plus 2y equals 20. Now, of course, a good strategy for these questions is to go through and find the equations of all the easier lines first, so that this one is left by process of elimination. But just to go through the principle one more time, let's say I picked a value like y equals 0, x would have to equal 20. That's this point over here, so that must be this line. Another strategy would be to rearrange it into y equals mx plus c format and look at the gradient and y-intercept. Now I'm interested in values where x plus 2y is less than, is below 20. I'm looking below, underneath this line, for values in here. If you're unsure, you can always pick a point and check. So if I pick this point over here, which is x equals 4 and y equals 6, 4 plus 12 is less than 20, so that's what I want, and therefore I want to shade above the line to get rid of these values. And we've been told to label this region R, so that's what I'm going to do. And that's inequalities question. So here we get a linear programming question, our last one on this worksheet. In 1 week, Naya spends X hours cooking and Y hours cleaning. The time she spends cleaning is at least equal to the time she spends cooking. This can be written as Y is equal to or greater than X. Now they have done this for us, but I'm going to stop for a moment and just explain why this is true. The time she spends cleaning, Y, is at least equal to the time she spends cooking. So it wants to be the same as the cooking time or more, and that's why they've written y is equal to or more than x. Cleaning time is equal to or more than cooking time. Now, we're going to have to make our own inequalities. She spends no more than 16 hours in total cooking and cleaning. Her cooking time plus her cleaning time cannot be more than 16, must be less than or equal to 16. She spends at least 4 hours cooking, so her cooking time, x, must be 4 or more, must be equal to or greater than 4. And so there's my next two inequalities. I now want to complete the diagram showing these three inequalities and shade the regions I'm not interested in. So I need to draw x plus y equals 16. Well, if x equals 0, y has to equal 16. So that would be going through this point. If y equals 0, x would need to equal 16, and that will be going through this point. So I now have 2 points to join together. Remember, you could pick any values. If x equaled 8, y would have to equal 8. So I could find another point over here if I wanted to. So now I'm going to join those points together with a straight line. It's a solid line because there's an equals included in my inequality. You can see my line is kind of wavy. In fact, I'm really unhappy with it, so I'm going to try again. You definitely need to be using a ruler for this in your exam. Now, I want x plus y to be less than or equal to 16. Less than, lower, below. I am interested in the area below this line. If you don't like that approach, once again, you can just pick a number below that line and see if it satisfies those conditions. Let's say I picked this point over here where x is 4 and y is 6. Well, x plus y, 4 plus 6 is 10. That's less than 16, so that satisfies this condition, and I would want to include it. That means I have to shade the other side of the line. So all of this stuff over here goes away. Now I need to draw x equals 4. This is just a vertical line going through x equals 4. Again, it's a solid line, and again, use a ruler. I'm interested in values where x is greater than 4. Now we can clearly see that's the right side of the line, so I'm going to shade the left side of this line. So we're left with this little triangle. She receives $10 for each hour she spends cooking. Well, if her cooking hours are represented by x, then for every hour she spends cooking, she's going to get 10 times x, 10x in total. $8 for each hour she spends cleaning. 8 times y will be the amount of money she gets from cleaning, and her total pay will be 10x plus 8y. And I want to work out the largest amount she could receive. Now, there's a couple of different approaches to this. It's going to be in one of the corners of this triangle that we've created. So it's either going to be here, or here, or here. Now you could just simply test all 3 points. This point down here in the bottom corner is x equals 4, y equals 4. You could put that into this formula and see how much money she got. But apply some common sense. It's clearly not going to be down here because that's the smallest amount of work she could be doing altogether. So we're not interested in this one. Now it could be either of these. They're both viable candidates. In the first point, in the highest point over here, she's doing the least amount of possible cooking and the most amount of cleaning. But she gets paid more for cooking, so I suspect it's not going to be that one. Here, we're doing a little bit more cooking, a little bit less cleaning. So at this stage, I would guess it would be this point, but I would also be quite happy to try that point just in case. So let's call this point over here A, and we're going to test A. That's where x equals 8 and y equals 8. X equals 8, y equals 8. That's 10 times 8 plus 8 times 8. She's getting $144 for her work. That's 80 plus 64. But maybe we think, well, okay, she's not doing as much cooking, but she's doing a lot more cleaning, so perhaps this one would be okay. You can test B if you want to, just to make sure. In general, whichever corner of this thing matches the thing I'm getting paid most for in this example would be the one we'd go for, but if you want to check, it only takes you a moment. So for B, I've got x equals 4, but y is now equal to 12. So I'm getting paid 10 for every one of those 4 hours, plus 8 for every one of those 12 hours. So 8 times 12 is 96, and 96 plus 40 is $136. So there's not much in it, and that's why it might have been worth checking. But we can see in this case her maximum pay is $144, and that's for going over here to this corner of the triangle. Now you may be wondering, well, this point over here strikes a nice balance in between the two. Why didn't we go ahead and test that point? Well, the short answer is that maximum and minimum values are always going to occur at the pointy bits, at the corners of these areas. But let's just test it just to see that this is in fact the case. At that mystery point in the middle, which is a nice balance between the two, we're seeing x equals 6 and y equals 10. So I'm getting 10 times 6, and I'm getting 8 times 10. That is 80 plus 60, which is $140, which is in between those two values. So the principle is that our maximums and our minimums are all going to occur at the points, not along the lines, and definitely not in the middle. That's why I focused on the points. It was pretty obvious that we wouldn't need to test this point down here, and the principle is that if I get paid more for x, then I'm going to go to where x is greatest, and if I was getting paid more for y, I'd go to where y was greatest. So in this case, I'm getting paid more for x. I'm expecting this to be the case, but no one's going to judge you for testing another likely point as well, just in case. And that's the end of the linear programming questions.